Okay, so here we are in part 3 of what might be a 4, perhaps even 5-part series. So for a total running time of almost 60 minutes, we have example 2 where we're calculating the radius of a cylinder knowing its volume. Okay, so previously mentioned the conversion between cubic meters and feet would be important, and the idea that the diameter is twice the radius would also be critically important. So let's deal with the unit conversion first. So here we have 2 feet. Okay, so this 2 feet, if we were to consider this relationship here, okay, what that's going to imply, or what that's going to mean, is that 2 feet would be none other than taking 0.3048 meters per foot and multiplying it by 2 feet, okay, which is going to give us a unit of measure in meters, okay. So if we double 0.3048, we're going to end up with 0.6096. So let's just double check the addition on that, and that stands to be correct. Okay, so we have that. Now for volume. So we're after the radius, which means we need to know the volume and the height. Well, we've got both. The volume is 1.5 cubic meters, and the height is 0.6096 meters. So let's substitute these values into our formula for volume. So we have 1.5 cubic meters is going to be equal to pi. So let me find that symbol here. It should be somewhere in this collection, and there it is. So pi times the radius, which we don't know, squared times the height of 0.6096. Okay, so in order to get the r by itself, that is to isolate it, we need to remove some of the other factors or the other numbers that are being used in multiplication. So we're going to undo the operation of multiplication, and that means that we should be dividing both sides, okay, both sides of our equation by 2 numbers. We're going to divide it by pi, and we're also going to divide it by 0.6096. So let's enter in the pi key again, and then 0.6096. So notice that that's going to have the effect of canceling both pi and 0.6096. And for excellent math communication, what we do to one side, we need to indicate on the other side as well. Okay. So now, let's tidy this up just a little bit so we can see what we're dealing with. So I'm going to rewrite this line here. And that's equal to r squared. So at this point in time, we need to undo squaring, which would mean that we need to square root both sides. So what we'll do is we'll indicate that right now. So I'm going to take the square root of that side as well as this side. And that's going to give us something equal to r. Okay. So we're going to take the square root of a squared measurement. which is going to give us something in terms of meters. So if we use our calculator at this point in time, so we need to determine the square root of that quotient, which is a division problem or an answer to a division problem. So it's 1.5 divided by pi. Okay, so I'm just going to press the equal sign, and then it's also divided by 0.6096. So that would be the value that comes underneath the square root symbol. Last but not least, we'll take the square root of this, and we end up with 0.8850. Okay, so as a final answer, 0.885, and that is meters. Okay, we'll indicate the units at this point in time. That would be the radius of the cylinder. Okay, and if you're unsure to check your work, you could substitute the radius and the height into the formula and calculate and get a volume of approximately 1.5. Okay, well, there's one more example in this series, and that is this one here. Okay, we're going to determine the volume of this particular stair-like structure to 2 decimal places. Okay, in the event that we were going to pour a concrete staircase, which is fairly commonplace. Okay, so in this one, we need to consider if there's a strategy, something that we can do that's going to make our work much more easy. So as we begin this, and we'll finish it in part 4 of our video series, recall how 1 meter is 100 centimeters. So we do have an obvious issue with our units. So it would probably make sense for us to convert into meters, and we'll end up, oh, we just changed a page there, and then we'll end up using smaller numbers. So 45 centimeters would be 0.45 meters. So let's use that. Notice that the base here, these sides are both of the same length. So when you're working with the volume of a figure that's non-traditional, something that just isn't like all of the other figures that you're used to, it's often useful to think of a strategy or a shortcut. One might be to consider this. This particular shape, if we were to fill in the top portion here, just what exactly would you have in terms of a shape? Okay, so let's just pull this out here. Notice how we have, if we were to break this down into a series of rectangular prisms that have square bottoms or square bases, you can see that there are a total of 6 of these. So if there are 6 here, how many would it take to fill in the top? Well, we would need 1 right here. We would need a second one here. Followed by a third one here. So 3 of them would fill in the structure. And you can see that here, 1 here, plus another 2. So I'm wondering if that would be useful. Much to say that if we found the volume of a full figure where the base is 45 centimeters squared, we could subtract the volume of the 3. But that might be just as much work as simply finding the volume of one of these and multiplying it by 6. Let's go with the second method, as it'll probably be shorter to do it that way. So because we're nearing the 10-minute mark of this video, we'll stop it here and we'll complete the calculation in part 4.